Hello everyone, this is video lecture number 3 on unit 5 of engineering chemistry spectroscopic techniques. In this video lecture we are going to study the terms involved in UV visible spectroscopy. First is chromophore. It is a covalently unsaturated group responsible for electronic absorption in visible region and imparting color to the molecule. So a molecule has color due to presence of a chromophore because it absorbs radiation in visible region. So it is a covalently unsaturated group, means it contains multiple bonds such as it can be nitrogen double bond oxygen, carbon double bond oxygen, carbon triple bond nitrogen, carbon carbon double bond, etc. Next is oxochrome. Oxochrome is a saturated functional group with non-bonding electrons that does not absorb the radiation in visible region, but when it is attached to a chromophore, it alters the wavelength and intensity of absorption. So oxochrome is a saturated functional group with non-bonding electrons like hydroxyl group, methoxy group, amino group, etc. So here the example is shown. Benzene is having lambda max 255 nanometer. Lambda max means the wavelength at which it shows maximum absorption, and it is the characteristic property of every molecule. So benzene has lambda max 255 nanometer, and you can see the structure of benzene. It is a covalently unsaturated group, means it contains carbon carbon double bond, so it is a chromophore. But to a chromophore, to benzene, when we attach the oxochrome, when we attach OH group, the wavelength of absorption lambda max is changed to 270 nanometer, means OH is a oxochrome. Again, if to benzene, if we attach a NH2 group which is a oxochrome, again the wavelength of absorption is changed to 280 nanometer. So oxochrome does not absorb radiation in visible region, but when we attach a oxochrome to a chromophore, it changes the wavelength as well as it can change the intensity of absorption of a chromophore. Next term is bathochromic shift, which is also called as red shift. When absorption maxima, means lambda max, of a compound shifts to a longer wavelength, it is known as bathochromic shift or red shift. Bathochromic shift can take place when we introduce a oxochrome, as you have seen in the previous example. That can be called as a bathochromic shift because benzene had lambda max 255 nanometer, but when we attached a OH group to benzene, the lambda max became 270 nanometer, means there was an increase in lambda max value. So it is an example of bathochromic shift or red shift. So bathochromic shift can occur when we attach a oxochrome to a chromophore, or it can take place when we change the solvent in which the molecule is present. For example, paranitrophenol shows red shift in alkaline medium. So when we take paranitrophenol in alkaline medium, the alkali abstract the hydrogen atom of OH group. So there is a shift in lambda max value, means lambda max value increases because negatively charged oxygen can delocalize electron more effectively in the benzene ring than the unshared electron present on the OH group. So first the lambda max value was 255 nanometer and then it became 265 nanometer. So this is an example of red shift. Next is hypsochromic shift, which is also called as a blue shift. It is the opposite to bathochromic shift. When absorption maxima, lambda max, of a compound shifts to a shorter wavelength, then it is known as hypsochromic shift or blue shift. Again, hypsochromic shift can take place when we remove conjugation, because in previous example we saw due to extended delocalization or due to conjugation red shift occur. So when we remove the conjugation, blue shift can occur. So example is aniline shows blue shift in acidic medium because it loses conjugation. When we take aniline having lambda max 280 nanometer in acidic medium, the lone pair of electrons which are present on nitrogen are no longer available for delocalization in the benzene ring, means there is a loss in conjugation or it loses its conjugation. So it is an example of hypsochromic shift or blue shift. Then it is hyperchromic shift. Now the first two effects which we studied, bathochromic shift as well as hypsochromic shift, were related to the wavelength of absorption. Now hyperchromic shift and hypochromic effect are related to the intensity of absorption. So when the intensity of absorption of a compound increases, it is known as hyperchromic shift. For example, pyridine has lambda max 257 nanometer, but 2-methyl pyridine has lambda max 260 nanometer. Its intensity of absorption increases because intensity of absorption of pyridine was 2750, and when we attach methyl group at second position in pyridine, the intensity of absorption increased to 3560. It is an example of hyperchromic effect. Hyperchromic effect can also occur when we introduce a oxochrome in the molecule. Next is hypochromic effect. Hypochromic effect can occur when there is a distortion in the structure of a molecule. So when absorption intensity of a compound decreases, it is known as hypochromic effect. Now here two geometrical isomers are shown. First is one is cis-cinnamic acid and another is trans-cinnamic acid. Trans-cinnamic acid has less steric hindrance. It is a more coplanar structure, so its intensity of absorption is more. It is 15900. But when we convert trans-cinnamic acid to cis-cinnamic acid, there is distortion in the structure of the molecule, so its intensity of absorption decreases to 10700. So let us summarize all the four effects. We have taken on y-axis molar absorption coefficient, on an x-axis wavelength. So the point at the wavelength at which we are getting the peak, it is called as the lambda max value, and there is a absorption peak. So when the lambda max value means the wavelength of absorption or the absorption maxima of a molecule shifts towards a longer wavelength side, means towards the right hand side, then it is called as bathochromic shift or red shift. When the absorption maxima of a molecule shifts towards the left hand side, means towards a shorter wavelength, it is called as hypsochromic shift or blue shift. When absorption intensity of the molecule increases, means peak height increases, then it is called as hyperchromic effect, and when the peak height decreases, it is called as hypochromic effect. So absorption maxima related to wavelength, there are two effects, bathochromic and hypsochromic, and related to intensity of absorption, there are two effects, hyperchromic effect and hypochromic effect. We'll stop here for this lecture. Thank you.